For this problem, let me write it a little bit bigger for you here. We're finding the value after t years, and um, running out of space over there. So making it a little bigger so you can see. We need to plug values for t into this equation, and the t is up here in the exponent. I'll go ahead and make that red up here. We just need to plug that number in and use a calculator to solve. So it says find the initial value of the car and then the value after 11 years. So just starting with the initial value, that will mean 0 years have gone by. So you would try to find v, the value after 0 years, means you're just going to put a 0 in here for t. So you're taking the number 0.84 and raising it to the 0 exponent. You can do that on a calculator. Anything to the 0 exponent is 1. So this whole thing will become 1. So it's 32,000 times 1, which means 32,000 is the original value of the car, the value after 0 years. So just backing that up here, if instead we're looking for the value after 11 years, we plug in 11 in here. And so 0.84 to the 11th, like I'm just doing this in Google here. So shift 6 gives me an exponent. You can do it any sort of calculator, Excel, use any device here to calculate this, raise it to the 11th power, and you get this number. And then I want to multiply that. If you look here, multiply that result by 32,000. So that result I got, if I hit multiply by 32,000, this would be the value here now after 11 years for that car. This problem is all about the rules of logarithms, just kind of some properties logarithms have. For A, these are both log base 9. So log base 9 of 7, and you add it to another log base 9. And it's saying that's going to equal, that's going to equal here to another log base 9. And here's our question mark. What would that be equal to? The rule of logs always says that if you're adding 2 logs together, you can combine them, simplify them into just, so you have 2 added together, you can simplify them into just 1 log. And the way you do that, it's always going to work. It's always going to be equal to the same value as if you multiply the 2 numbers together. So when you're adding 2 logs, multiply the numbers together. This would be 56. You can check this on a calculator, log base 9 of 56. I don't know if Google can do base 9, but I know Excel can, or some different calculators, but this value comes out to exactly the same as if you add them separately. And if addition goes with multiplication, subtraction goes with division. So the second one here is having two logs subtracted, and it's saying the result is log base 7 of 4 divided by 7. Over here was log base 7 of 7, or sorry, it might be log base 3. It's kind of hard to see. The base is the same everywhere. Well, I think it's 3. Log base 3 of 7, log base 3 of 4 over 7, and log base 3 of some blank that we don't know. 2 things subtracted, 2 of them subtracted, can be combined into 1 log if we divide the numbers. And so the numbers being divided here are 4 divided by 7, so this right here must be a 4. You subtract a 4 minus a 7, it can be combined into 1 log 4 divided by 7. And so those 2 rules of logarithms or laws of logarithms, and then there's one more, and it says any exponent you can actually take out to the front if you want, so and change it to multiplication. So here I'm looking for the blank to fill in here. I have a number multiplied out in front. So that could have been an exponent on the value inside the log. So log base 2 with the number multiplied in front, I could rewrite that as that value 5 here to the second power, that whatever it's being multiplied in front can be written as an exponent on the inside, or anytime there's an exponent on the inside, you could remove that exponent and write it back in the front here as multiplication. So here you're trying to draw f of x. Our function here is 5/4, number 5/4 raised to the exponent of x. Let's go to Desmos graphing calculator. This is a good online graphing calculator just to see what this should look like. 5/4 raised to the x. Yep, I did that wrong. 5/4, that whole entire value raised to x. There we go. And so it's going to look like a typical exponential function. It starts to go up super fast once you get past 0. It just kind of shoots up exponentially. And notice kind of here on the horizontal negative direction, it gets closer and closer to the x-axis, but it never quite touches the x-axis. It almost looks like it's right on top of it. And that's how it's always going to go. The x-axis is the asymptote. That is the line the graph gets closer and closer to, but never quite touches. And so that is one thing you're going to have to graph. And you're also going to have to graph some points that the line passes through. Now I think you just need, I'm not sure how many points you need to graph. I think maybe just a couple will work. If you plug anything to the 0 power, it's 1. So when x is 0, your y value is going to be 1. If you put a 0 in there for x, you get the result of 1. And if you put a 1 in there for x, you'd have 5/4 to the first power, so you get 5/4. And you could mess around with a calculator and find a few more points if it needs you to have more points. I don't think it would. 2 probably will work, but like 5/4 to the second power is 1.5625. So where were we at? So if you put a 2 in there for x, you get 1.5625. So that's how you can find some points. Just plug different values in here for your exponent for x and see what the result is and y. And you need to click on, I think it's this button right here, for plotting points. Make sure that's selected, and you should be able to type these coordinates in, the x and the y. Type them in, and once you have a few points plotted there, you have to click on this then and graph the asymptote. Now, like I mentioned, that is the x-axis. The line gets closer and closer to the x-axis here. It never quite touches it. It just goes down, down, but never quite reaches the x-axis. So after you've selected that dashed horizontal line, you need to click on the x-axis in 2 spots so that it knows. Maybe you can just click in 1 spot since it's a horizontal line already, but make sure you click once on the x-axis. I think the dashed line will show up. If not, click somewhere else on the x-axis to kind of, connect it with 2 horizontal spots or 2 points horizontally, and it should draw a dashed line on the x-axis. And then you have these points already plotted that you did with this one. After that, I think this button is called graph a function button. So after you've done those 2 things, plotted points, plotted the horizontal asymptote, then click on the graph a function button, and it should draw your complete graph.